Okay, so we're going to be talking about two ideas today. It's going to be the concept of weak versus strong acids first, and then this idea of acid concentration versus acid strength. So first thing, let's start with what makes an acid weak versus strong. Usually when we hear that term, we tend to think about, oh, a strong acid can like eat through anything and it's this super kind of powerful destructive force, and weak acids aren't. That's not entirely the right idea. We can divide it into two categories. The strong acids are over here. This is over by Rosie the Riveter here. The strong acids are basically 6 of them: nitric, hydrochloric, sulfuric, perchloric, hydrobromic, and hydroiodic. And these are classified as the strong acids. All other acids are classified as weak acids. So one that you might be familiar with or know of in some way, this is carbonic acid, and carbonic acid is what they put in sodas, like in sparkling water or anything with bubbles, is usually bubbly because it has some carbonic acid. So what I want to do is show you what makes a strong acid strong and what makes a weak acid weak. Like all things with acids and bases, it doesn't have anything to do with the formula. It has everything to do with their behavior. And I want you to think about it in terms of kind of dating and relationships. In each of these acids, you can think about there's a hydrogen component, right? And that's what makes it acidic, versus a anion component. So the hydrogen is kind of taking the place, that's the cation, and then there's an anion. So let's look at hydrochloric acid, because that's a really simple example. Hydrochloric acid can kind of exist in 2 states. It can exist together, bonded here, HCl. It can also do what we call ionize, or we can say it ionizes. And when something ionizes, all that means is that it breaks apart into ions. So HCl is made up of 2 ions. It can look like H plus and then Cl minus. So you kind of have your 2 options there. And I'm going to rewrite this down here in a minute. You'll see why. So we have HCl together, kind of bonded, or the 2 ions, H plus and Cl minus. So it's one of those, they're existing together, maybe in the same solution, but they're not physically bonded together. Now, what makes this acid a strong acid has to do with how much time it spends together versus how much time it spends apart. The ions, the H plus, is what actually gives it its acidic behavior. And so what happens is that because HCl is a strong acid, it spends more of its time apart. It's kind of like, think about that couple that you know who they break up and then they get back together and then they break up and then they get back together, and it's like this emotional roller coaster. This is kind of like that. Strong acids spend more of their time broken apart than they do bonded together. I'll say that again because it's important. Strong acids spend more of their time broken apart than they do bonded together. They're ionized more often than not. So acidic behavior, I'm going to say due to frequent ionization. It's more frequently ionized than not. How do we show that? This is going to be, if you're typing these notes in, you might have to experiment with maybe some font size or something like that. But we do it with arrows. And so what I would say is the HCl is constantly going back and forth. It's breaking apart, it's getting back together, it's breaking apart, it's getting back together. How we show that is with arrows. We can say, yep, HCl very frequently will break apart into hydrogen ions and chlorine ions. Every so often, though, they will get back together. Those 2 lone ions will reform into hydrochloric acid, but not as frequently as it breaks apart. So watch how we show that here. 2 arrows of different sizes. The big arrow pointing to the right is communicating that, you know what, this acid spends a lot of its time broken up. The right-going reaction happens much more frequently than the left-going reaction. So it spends more of its time being ionized than it does being together and bonded. So that's what makes a strong acid strong. The weak acid, it's kind of the exact opposite. Weak acids over here, weak acids spend less time ionized. They are together more often than they break apart. So for our example, like H2CO3, that could break up. If we pull off one hydrogen, we're going to be left with H plus and then HCO3 minus. So we're left with kind of those two pieces. For these arrows, we want to show that carbonic acid, it spends more time as H2CO3 than it does as H plus and HCO3 minus. So the arrows are going to look the exact opposite of the strong acids. You're going to see a big arrow going to the left and a little arrow going to the right. And again, that's to indicate we spend way more of our time in weak acids bonded together than we do broken apart. So that's what it means to be a strong acid versus a weak acid. It all comes down to how long it's ionized or how frequently it ionizes. The other part is concentration versus strength. And this is another idea that people tend to get a little confused. Concentration of an acid is not the same thing as the strength of an acid. So it's kind of easiest to break it apart into two ideas. The strength of an acid is kind of like what we looked at above. The strength of the acid only refers to its ionization. More ionization equals a stronger acid. Equals stronger acid. Concentration has nothing to do with ionization level. Concentration, right? You remember how we measure this? This is chemistry. So we measure concentration in molarity. And all that tells us is that tells us moles per liter of the acid dissolved in water. So you can have, and this is what kind of blows people's minds a little bit, you could have a low concentration of a strong acid. So that might mean something like, we could say that would be like 0.1 molarity of, let's pick a strong acid, pick something from the big six up here, HCl. That would be an example of a low concentration of a strong acid. You could also have a high concentration of a weak acid and anything in between. So we could have maybe 10 molar H2CO3. You could also have kind of all of the other pairings. You could have a low concentration of a weak acid. You could have a high concentration of a strong acid. So I just wanted to show you that so you get in your head that strength of an acid is not the same thing as concentration.